Hello everyone. I just want to continue with my previous video on the equivalent trig functions, and I'm going to show you another type of equivalent expressions involving multiple periods with a different phase shift. Okay, so we have gone through the equivalent expressions using the related IQ angle, and also the second type is the cofunctions identities. Now, I want to bring all of you back to the graph of the trig functions, such as the sine functions, for example. Okay, so I have a sine functions here, the parents function of the sine functions. And if you look at the sine functions, like I have mentioned it before, if we are using or depends on the starting point that we are using. So in the parents functions of the sine, the starting point is right at the point of origins. But if I'm going to choose a different starting point, such as this one here, then this sine functions, I can write it in terms of cosine as a cos of a theta minus the pi over 2, because it has a phase shift of a pi over 2 over here. Okay, so these two expressions are equivalent. Or if I'm choosing another one, okay, if I'm choosing another one, let's say if I choose this one here, okay, as my starting point, okay, where it starts on the equation of axis, then I can also give myself another sine functions, but with the phase shift of theta minus the pi, because it starts at minus the pi here. But I also have a negative amplitude, because from this starting point, I start going to the minimum instead of going to the maximum. Okay, so that's why I need to have a negative. But again, if I'm using another point like this one as my starting point, the minimum, then I can also give myself another functions in terms of cosine. But because I'm starting from the minimum, so I need to have a negative amplitude, and then with the phase shift of a 3 pi over 2. So this kind of equivalent expressions and depends on the starting point that we are going to use, and with the different starting point, then we will also have a different phase shift. Okay, so that is the other type. Now I want to go over the example number 3 together with all of you, so that you get to see some of the equivalent expressions there. Okay, now example number 3 is asking, state whether each of the following are true or false. And in order for us to decide whether they're true or false, first of all, we have to make sure that the theta that I have on the expression, that theta, this angle here, is less than 90 degree, less than a pi over 2. Okay, so think about the example number 8. When I have a sine of a theta minus a 2 pi, would that be equal to sine theta? Okay, so I want you to look at a graph that quickly draw yourself this graph right beside it. So think about the left side. If I have a theta that is less than 90 degree, so a positive theta, that means you always start from the initial positions here. Okay, and if you are going whatever that theta is, but it's under 90, so it's going to happen somewhere here. Okay, somewhere here in the quadrant 1. But then you have a minus 2 pi, so that means from this angle theta here, you're going back, because this is minus, for a 360 degree. Okay, so you are back on this point here. So you will end up in the quadrant 1. So for the sine in this quadrant, according to the Cass rule, it is a positive. So this entire expressions here is going to be positive, because it will end up in quadrant 1. And sine theta is also in quadrant 1. So this is a positive. So therefore, for this particular questions, and the answer is going to be true. Okay, so let's look at another example underneath here. So I have a sine of a 2 pi minus theta equal to sine theta. Well, then, of course, I know that from my previous example, I have a sine theta is with a positive because a theta is less than 90. So it will end up in quadrant 1. Okay? So, but on the left side here, if I start from the initial positions and I have a 2 pi first, so I go from here, 2 pi will go into here. But then, because of a minus theta, so I have to go from here and I go back to the negative positions for this much for the theta. So I ended up in quadrant 4. So sine in quadrant 4, according to the CAS rule, is a negative. So that means this expression here is going to be equal to negative, but I have a sine theta equal to a positive. So therefore, the answer for this one is going to be false because they're not matching with the sign. Okay, they're not matching with the sign. So with the same idea, moving on to part C, cos of a pi minus theta equal to minus a cos theta. Okay, so let's look at the diagram here. On the left side here, if I have the pi first, so from the initial positions, I go up to here, and then I'm going to minus the theta. So that means I'm going back to this much. Okay, so I ended up in quadrant 2. So in quadrant 2, if you look at the CAS rule, quadrant 2, I have a cosine as a negative. So that means this expression's here. Cos of a pi minus theta, I'm going to get negative. But cos theta is positive, but positive with a negative, you're going to get negative. So a negative should equal to a negative, so this one is true. Okay, and the next one, the sine of a pi minus theta. So think about, I have a pi, so positive pi going to this directions, but then from here minus theta, that means I'm going back to this directions. Okay, so I ended up in quadrant 2 again, but sine in this quadrant 2 according to the CAS rule is positive, so this is going to be positive. And think about a sine theta. Sine theta itself in quadrant 1 is positive, but with the negative. So that means this will give you a negative. So this one here, D, is going to be false because the sign does not match. Okay? Now, for E, tangents pi plus the theta. So pi again, positive, go into here. Plus theta, that means continue moving into the positive directions. So I will have ended up in quadrant 3. And quadrant 3, in from the CAS rules, quadrant 3, tangent is positive. So all of this is going to be equal to positive. And tangent theta, again, is in quadrant 1 because theta is less than 90. So this one is also positive. So this one is true because a positive should equal to a positive. And finally, F, okay, you have a cos theta. Well, cos theta is always positive. We know that this is in quadrant 1, right? But the others, the theta plus 6 pi. So think about a theta is going to be going this much, but then with the 6 pi. So you're going to 2 pi, 4 pi, 6 pi. So you still ended up in here in quadrant 1. So in quadrant 1, cosine here is also positive. So that makes F as a true. Okay, positive and a positive. And the next example is cos theta. So cos theta again is positive, but negative, cos of a negative theta. Okay, so this one is a little bit tricky here. So let's draw this. And if you have a cos of a negative theta, that means you are going into the negative directions, okay, for the negative theta. And then this will be in quadrant 4. Quadrant 4, cosine is positive. Okay, so this much here is going to be a positive, but then a positive with a negative will give you a negative. So this one here is going to be a negative, so the answer is going to be false, because a positive over here and a negative over there, so they don't match. Okay, so that makes it false. And finally, a cotangent of a theta plus pi, and a cotangent of theta. Okay, when you look at the cotangents, it even though this is the reciprocal, but this is the reciprocal of the tangents, right? So if you look at the diagram here, okay, cotangent theta, that means when the theta is going up this direction, positive, and tangent and cotangent will share the same sign. Okay, it doesn't change. So this one here basically is going to be positive because tangent theta is going to be positive. So cotangent, the reciprocal, will also share the same sign. Okay, same thing here. When you have the theta, okay, so this is your theta to the positive directions, and then plus pi. So that means you're going to go 180 degrees. So 180 degree will go in here. Okay, so in quadrant 3. So tangents in quadrant 3 is positive. So does the cotangents. Okay, so this one is going to be positive as well. So that makes this true. Okay.